All right, so now we're going to talk about something called named entity recognition, or NER for short. Now, in the real world, in our daily conversations, we don't work directly with the categories of words. Instead, for example, if we want to build a Netflix chatbot, we want it to recognize both Batman and Avatar as instances of the same group, which we call films. But we want it to recognize that Steven Spielberg, on the other hand, is the entity called director. This concept of semantic field dependent of a context is what we define as an entity. The role of a named entity recognizer is to detect relevant entities in our corpus. The process of detecting the named entities, such as person names, location names, company names, etc., is called NER. As an example, take this sentence. Steve, the CEO of Apple Inc., is living in San Francisco. So Steve would be the person entity. Apple Inc. would be the org or organization entity, and San Francisco would be the location entity. So the first thing we'll do is we'll download the one NLTK package. So we'll do nltk.download, and then we'll pass in parentheses and double quotation marks maxent_ne_chunker. All right. So here's a little look for you at some of the commonly used types of entities. So we've got organization, person, location, date, time, money, percent, facility, and GPE, which is geopolitical entity. Next thing we're going to do, I want to load this image to just show you something here. So we'll do from ipython.display import image, and then next line image, and we'll pass through NR in big letters underscore architecture.png, and we'll pass that, and this is the image that you will get. So what the image below shows us is the architecture for a simple information extraction system. It begins by processing a document using several of the procedures that we've discussed before. So first, the raw text of the document is split into sentences using a sentence segmenter, and each sentence is further subdivided into words using a tokenizer. Next, each sentence is tagged with part-of-speech tags, which will prove very helpful in the next step, named entity detection. In this step, we search for mentions of potentially interesting entities in each sentence. Finally, we use relation detection to search for likely relations between different entities in the text. Now, we should keep in mind, because models are statistical and strongly depend on the examples they were trained on, this doesn't always work perfectly and might need some tuning later, depending on your use case. Okay, so now we're going to import an LTK and sentence equals, and we'll copy the sentence that we talked about earlier. Steve Jobs, the CEO of Apple Inc., is living in San Francisco. And what we're going to do is first tokenize, and then POS tag, and then chunk the entities that we just talked about. So we're going to do tokens equals nltk dot word underscore tokenize, and then we'll pass sentence. So the sentence that we wrote above, we're passing it as an argument to tokenize. And then next line, chunks equals nltk.ne underscore chunk, and then we'll pass with parentheses nltk.pos underscore tag, and then opening parentheses tokens, and then two closing parentheses, and then we'll type in chunks, and here is the output that we get. Next line, we're just gonna write for chunk in chunks, colon, and then we'll just print, and we'll pass chunk. And then next, we're going to type in for chunk in chunks colon if HASATTR opening parentheses chunk comma apostrophe label apostrophe closing parentheses and then colon, and the next line print opening parentheses chunk dot label opening parentheses closing parentheses comma, and then one apostrophe and a space and another apostrophe dot join opening parentheses C opening square brackets 0 closing square brackets space here for C in chunk and then two closing parentheses. Okay, as you can see, it has recognized Steve as a name, but it's recognized Jobs as a GPE. Since we used the simplest way of NER, which is embedded in NLTK, it's not strong enough to catch these kinds of consecutive entities as one. In practice, we generally use much stronger and efficient NER packages such as the Stanford NER tagger, Spacey, and so forth. So what we're going to do here is we're going to apply these NLP procedures with the Spacey package. Applying all these processes with Spacey package is quite easy and straightforward. We should decide which package to use by checking the accuracy or any other metrics that we want to deal with. So I'm going to actually just copy and paste this code in as our video is getting up there in time. And I'll just quickly explain it. What we're doing here is we're first importing the Spacey package and we're loading the English parser. Then we dump any of the text into this parser and Spacey will apply the various pre-processing methods as the default. All we need to do is to use the relevant functions to extract what we want, such as tokens, lemmas, POS, etc. And here is the code for the lemmatization and POS portion. And then what we're going to do is we're going to view this parsing in pandas data frame. And once again, I will copy this part. And the final part that we're going to do here is we're going to type import Spacey and then NLP equals Spacey dot load, and then we'll pass en with apostrophes around it. And next line we'll do doc equals NLP, and then in parentheses with the double quotation marks around, we're going to copy and paste the Steve Jobs, the CEO of Apple Inc. is living in San Francisco. And then we will type in for ent in doc dot ents colon, and then print next line opening parentheses ent dot text comma ent dot label underscore and closing parentheses. And what we get here and what we see is that without applying any other procedure, with just a few lines of code, Steve and Jobs are recognized as one